Hello everyone, I am Professor Ranjit Singh. I am Dean Affiliation at Shri Vishwakarma Skill University, Palwal, Haryana. I am Chairperson of Industry 4.0. In the last video, we have seen the logic gates. Today, we are going to discuss the Karnaugh map method which help us to express the optimized Boolean expression. The aim and focus of this topic is to understand and have the knowledge of Boolean expression. The person will be able to optimize the Boolean expression. The third outcome of this course will be the analysis and synthesis of the Boolean expression. Now, Karnaugh map is also popular by the name of K-map method. In this method, we will see how to reduce the Boolean expression. Before we starting the K-map method, I would like to share the 3 or 4 important things which are connected with this method. The first one is the Boolean expression. Boolean expression is the logical expression which is an equation representing the input and output variable. The third one is the binary number system. How to represent the binary number system? The binary number system can be represented from 0 to 7 as shown in this table by this manner. If the binary number is 0, then the value at 3 terminals will be 0, 0, 0. And if the binary number is 7, the input at the 3 terminals will be equal to 1, 1, 1. Suppose the binary number is 4, under that condition the input at terminals will be equal to 1, 0, 0 as shown in this diagram. So this is the binary number representation, how to represent the binary number system. The second important thing which is to be discussed here is the SOP and POS. SOP is known as sum of products. The Boolean expression can be represented in 2 categories, one as a SOP, the another as a POS. SOP is known as sum of products. If we will represent the product variable which are summed together in the expression, we will call that as a SOP. And POS is the product of sum. If we will have the expression which is the combination of summation and their product, that is known as product of sum. Both the representation SOP and POS can be usually given like this. The third important thing to be covered here is the mean term and max term. The mean term is normally associated as a sum of the products, and normally it is shown by a small m with a summation sign, while max term is associated or connected with the product of the sum expression, and it is normally represented by capital M with a symbol of pi as shown here. So the mean term and max term can be represented like this. Karnaugh map is a pictorial representation of the Boolean representation or the Boolean variables. These all variables are presented in a table that is called K-map table, which is designed with the various cells. K-map provides us a systematic method for the simplifying of the Boolean expression. K-map does the grouping of the Boolean variables together to optimize the Boolean expression. This will lead us to the low cost of the digital circuit, which is the objective of every science or the technology. The second important point on the K-map is it will produce the simplest version of the sum of the product or the product of the sum. The third important point is that it will cover all the possible variables which are present in the digital circuits. So, K-map is very important and plays a vital role in the digital electronics design because it is covering all the variables available in the digital circuits. K-map represent the transformation of all the values available in the Boolean truth table into the K-map table. In this method, we can have the representation of every value which are available in the truth table inside the Karnaugh map table. The Karnaugh map table will be the representation of the two values, that is 0 and 1. It will visualize the only logical values which we are using for the logic gates, that is normally represented as 0 and 1. Now, with the K-map, we can reduce the Boolean expression of any number of the variables. It will be good to use this method for at least 6 number of the variables. K-map is designed by the use of the cells. The cells is nothing, it is a positions of the values of 0 and 1 according to the number of the variables used for the digital circuit. If the number of the variables are n, in that category the total number of cell will be 2 raised to power n. As I was saying, it is better to use the K-map method for at least 6 variables. Now let us discuss the case of 2 variable. Under the 2 variables, we will have the K-map table equal to 2 raised to power 2. That means we will require the 4 cells for K-map table, which can be shown like this. If we are using the mean terms, under that condition we will use the product terms A into B. If we are using the max terms, we will use the sum terms, that is A plus B, as which has been incorporated in this K-map table. If the number of the variables is 3, under that condition we will have the 8 cells in the K-map table, which can be represented like this. In this case, we are looking that one variable is toward y-axis, that is A, which is equal to 0 or 1, while the two other variable B and C are toward the x-axis, and that is the B and C equal to 0, 0, 0, 1, 1, 1 and 1, 0. By this arrangement of the cell, we will have the K-map table to be pictorially given as like this. Now, let us take the another case. If the variables are 4, now there will be 16 cells which will club together to give the Karnaugh map table, which can be shown like this. In this case, we have taken the 2 input across the y-axis and another 2 input across the x-axis, like 0, 0, 0, 1, 1, 1 and 1, 0 toward the x-axis. The another values which are represented at C and D as 0, 0, 0, 1, 1, 1 and 1, 0 toward the y-axis, and this will give us the representation of Karnaugh map table for 4 variable. Now similarly, we can have the Karnaugh map table for 5 variables, which can be represented like that. In this condition, we are taking A is equal to 0 at one point, in which the another 4 variable B, C, D, E are considered separately, and when a is equal to 1, we are considering the another 4 variable at second point as shown here in this table. Similarly, we can have the Karnaugh map table for 6 variable, in which we will consider the cells is equal to 2 raised to power 6, that is 64 cells are required to prepare this Karnaugh map table. Now let us discuss one example for this case. Suppose we have the OR gate as shown here. We know that the truth table of OR gate is given like this, in which we will have the output is equal to 0 at both input 0 and 1 output at when there will be high voltage at any terminal. Now from this Boolean truth table, we will generate the Karnaugh map table. We will place the values of the Boolean truth table into the Karnaugh map table. We are looking that when a is equal to 0 and b is equal to 0, we will place the 0 at this position. Now similarly, when we are having the 0 as a and b is equal to 1, the output is 1, so we will place this 1 at this cell. Similarly, the third case, in which when a is equal to 1 and b is equal to 0, we will place the 1 at this cell, and when there is both equal to 1, where we will place the 1 at this cell. Now Karnaugh map table will represent like this, in which we have placed 0 and 1s at their cell locations. Now we have to make the groupings according to this Karnaugh map method. We are making the grouping in this Karnaugh map table. We are looking that there is a one group of 2 1s that is located at this red circle, that is represented like a red circle. Now in this case, we are looking that this is a one group. Under this group, we are looking that the value of a is changing while b is kept constant, because in this group a is changing from 0 to 1 while b is 1 at the same group. So the logical expression of this group will be equal to b. Now we will prepare the another group that is like blue circle. In this case, we are looking the a is constant while b is changing from 0 to 1. Now the Boolean expression for this group will be equal to a. Now if we have to calculate the overall expression of this Karnaugh map table, that will be equal to sum of both the values, that is equal to a plus b. In this case, the output is equal to y, that is equal to a plus b, which fulfills the logic expression of OR gate. Now let us see the another example. In this example, we have the Boolean truth table available like this. Now we will place all the ones which are placed at Boolean truth table into the Karnaugh map truth table at their cells. Now we will place all the zeros at their cell locations. Now after placing all the ones and zeros of the truth table into the Karnaugh map truth table, now we will make the grouping of these variables. Now we are looking that there is one group like this red circle, which is a group of 4 ones together. In this case, we are looking that value of a is changing from 0 to 1, while the value of b is constant, that is 0 to 0, and the third variable c, that is also changing from 0 to 1. Now we will leave all the various variable which are changing. We are supposed to take only that variable which is unchanged. in this grouping the B is unchanged, so we are taking or we are considering B for the Boolean expression, that is 0. So we will represent B as a B bar, because in this case the value of B is constant, that is equal to 0. So we are representing this one group of all four as a B bar. Now we have to look upon the another groupings. In this case we are looking that we can prepare one group from end to end positions, and which is represented like this. In this case again we are looking the value of A is unchanged and the value of C is also unchanged, while the value of B is changing from 0 to 1. Now in this case we will have the expression from both the variable, that is A and C. In this case the value of A is 1 while the value of C is 0. So it will be the product of A and C which will be represented like A into C bar. Now we have to look upon the another groups to be available in this Karnaugh map table. We can prepare one group like this. In this example we have seen that there are two groups which are giving us the two expression, one as a B bar, the another one as a into C bar. So the optimized Boolean expression of this truth table will be equal to B bar plus A into C bar. Now let us see the another example of this case. In this case we are looking that it is a case of min terms, because summation is given at location of 4, 5, 12, 14 and 15. So we will place the values of 1 at these cells, that is 4, 5, 12, 14 and 15. So we have placed the value of 1 at these location. Now we have to make the groupings. We are looking that there is a one group like this red encirclement. In this red encirclement we are looking the value of A is changing from 0 to 1 while B is constant. Similarly we are looking the value of C and D is unchanged, that is equal to 0, 0. So in this grouping the expression, after placing all the variable in the cells, we will prepare the various grouping which are occurring in this Karnaugh map table. We are looking that there is one group like this. In this case there are three groups which are generating from this Karnaugh map table. After placing all the variables, we are looking that there are three groups which are occurring in this Karnaugh map table. That is one group like this, second group like this and third group like this. Now we will find out the Boolean expression for every group. For first group we are looking the value of A is changing because AB is equal to 0, 1 to 1, 1. Now we will find out the expression for first group. In this first group we are looking the value of A is changing from 0 to 1. So we will not consider the A variable. While the all other variable are unchanged in this group, the value of B is 1 while the value of C and D is 0, 0. So the expression of this first group will be equal to B, C bar and D bar. Now let us see the second group. In this second grouping we are looking the value of A and B is constant, that is 1 and 1, it is not changing, while the value of C and D, in this case the value of D is changing from 1 to 0 while value of C is 1. So in this group value of A is 1, B is 1 and C is also 1. So the Boolean expression of this group will be equal to A into B into C. Now let us see the expression for third group. In this third group, we are looking the value of A and B is unchanged. The value of A and B is 0, 1. It is not changing. While the value of D is changing from 0 to 1. So we will ignore the variable D because it is changing from 0 to 1, while the value of C is 0. So in this third grouping, the value of the Boolean expression will be equal to A bar B into C bar. So overall Boolean expression of this example will be equal to, that is y is equal to A bar B into C bar plus B into C bar D bar plus A, B and C. Now let us take the one more condition that is very important condition in the Karnaugh map, which is known as don't care condition. This is a situation arises in which the input variable is not to be considered. It can be considered as per the desire of the engineer or the scientist or the researchers. This can be equal to 0 or 1 according to the desired condition or the requirement of the digital circuit. So don't care term can be either 1 or 0 in the case in this condition. Now let us take an example of both the cases, that is the max term and the don't care condition. We will place all the values of the max term into the cells at their locations, and we will have the don't care positions like a cross at every cells. So we will have the Karnaugh map like this. Now in this case we have to prepare the groupings. Now the first group is arising like this. Second group which is occurring in this Karnaugh map table is like this. Now we have to find out the Boolean expression for the first group. In the first group we are looking the value of AB is unchanged while the value of C and D are changing. Because this is a case of max term, so we will take it as a product of the sum, that is A plus B bar as an expression. In the second grouping, we are looking the value of C and D is not changing while the value of B is changing from 1 to 0. So the expression of this second group will be equal to A bar plus C plus D. So overall expression of this example will be equal to Y, which will be the product of both the Boolean expressions. So this was all about the optimization or minimization of the Boolean expressions. Now you can use this optimize expression for the design of digital circuit, which will help us to reduce the cost of the circuitry. Namaskar, Dhanyavad.